Good morning, students. Welcome to video lecturing class for control engineering. So we'll continue with the problems on Bode plot. So here is the statement: g of s equal to 40 into s plus 5 divided by s into s plus 10 into s plus 2. So draw the Bode plot and determine gain margin, phase margin, omega gc and omega pc, and comment on its stability. So first you need to obtain the given function into time constant format, that is g of s into h of s equal to k into 1 plus ts divided by s into 1 plus ts plus 1 plus ts. So to get in that form, so I will take 5 from this as the common term. So it will be 40 into 5, 1 plus s by 5, 10 from this. So it will be s plus, 1 plus s by 10. Similarly, 1 plus s by 2. If you simplify that, you will get the standard for time constant form equation as 10 into 1 plus 0.2 s divided by s into 1 plus 0.1 s into 1 plus 0.5 s. So this is the first step. The second step, you need to identify the factors. So here the k value is 20. So 20 log k, that is 20 log 10, will be 20 dB. And 1 by s is at origin, the simple pole, whose frequency will be 1 radian per second. Then the second pole is 1 divided by 1 plus 0.5 s, slope will be minus 20, and omega c1, that is first break frequency, will be 1 divided by t1, which is equal to 1 by divided by 0.5, which is equal to 2 radian per second. Then I will consider the 0 here. 1 plus 0.2 s, slope will be plus 20, and omega c2 will be 5 radian per second. Similarly, for the next pole, so slope will be minus 20 and omega c3 will be 10 radian per second. So here we need to construct this table: terms, slope, magnitude, break frequency, and cumulative slope. And here, while considering this 0, so I consider this 0 before this pole, because the frequency of this pole is less than the last pole. Frequency of this 0 is last pole. So when you write the frequency in this column, it should be in ascending order. Like that, you have to select the term here. Don't get confused that, or it is not meant that first you have to consider always the poles, then zeros. It is not like that. So here, this frequencies should be in increasing order, ascending order. So like that, you have to write the term here. Okay. So for that, the cumulative slope will be, first one will be minus 20, and this minus 20 will be minus 40, and minus 40 plus 20 will be minus 20, and minus 20 and minus 20 will be minus 40. So this construction of this table is also important for considering the order of the terms. Next, you need to construct the phase angle table. For that, this tan inverse of 0 omega by 40 plus tan inverse of 2 omega and minus tan inverse of omega by 0 minus tan inverse of 0.5 omega by 1 minus tan inverse of 0.1 omega by 1. So construct this table, select the various values of omega. So here, while selecting, first you start with the minimum value as 0.1 or 0.2, then 5, 10, 50 and infinity. So here I am neglecting this term because this will be 0. So it is only this term will be with plus sign and remaining with negative sign. So they calculate their respective angles and get the resultant angle, that is pi r. So when this omega is 0.2, the angle is 94.56. Likewise, for the different values of omega, we calculate the values of phase angle. So after this, we have to go for the construction of the Bode plot. So this is the plot. The first step is, first you need to take the proper scale. Okay. So on this y-axis, 1 unit I have taken it as 20 dB, and here 1 unit I have taken it as 30 degree. So first draw a line at 0 dB. Okay. Then you need to draw a line that 20 log k line, because here in this statement he has given that the k value is 10, so that value will be 20 dB. So now I have to draw this line. After that, mark a point on 0 dB line where the omega value is 1. From that point, you draw the line to 20 dB, 40 dB and minus 40 dB slope. After that, you need to shift the plot, or you need to shift this 20 dB first line on this k in such a way that this slope should remain same. That is, from 40 to this point, your slope will be minus 20 only. And this will continue up to the next frequency. So next frequency is 2 radian per second. So up to this 2 radian per second, the slope of this line should be minus 20. After that, the next break frequency is 5 radian per second. So from 2 to 5, it will be parallel to this 40 dB line. Okay. So this line, slope of this line should be 40 dB. Then from 5 to 10, the slope will be minus 60. So from 5 to 10, that is from 5 radian per second to 10 radian per second, the slope will be minus 60. So like that you have to draw. After that, it will be minus 40 only. Okay. So that is the cumulative, sorry, it is not minus 60, it is minus 20, because in this table, it is cumulative table for this 0, it is minus 20 is the slope. Okay. So that means from 5 to 10, it will be with 20 dB only, minus 20 dB line should be parallel to this 20 dB line. After that, it will be minus 40 till infinity. Okay. So this is the magnitude plot. Then for the phase plot, you have different values of omega and you have the respective angles. So mark those points, that is, take x-axis as omega value and y-axis as angle. So mark those points and join those points with a smooth curve. So after that, you need to identify the gain margin and phase margin and the omega GC value and omega PC value. So here, if you see this phase plot, or if you see this phase table, at infinity only it is minus 180. Okay. So that means nowhere it is having the intersection with 180 degree line. So from that we can assume that our gain margin value will be infinite dB. Okay. And then you observe this phase table, sorry, magnitude line, and look for the intersection of this magnitude line with 0 dB. Wherever it intersects, from there you draw a vertical line till this x-axis. Okay. And the distance between this 180 degree line and this phase plot will be the phase margin, and the respective frequency on x-axis will be the omega GC. That is, omega GC is 4.4 radian per second in this case. So omega PC will be infinite because nowhere it is having intersection with 180 degree line. It is having intersection with 180 degree line at infinity. Okay. And we can say that the system is absolutely stable. That is the comment which you need to write at the end. Okay. So first step is 0 dB line. After that, mark a point at omega equal to 1, draw the slope lines, then shift that first line on this 20 dB line because the k value is 20 dB, then continue that line with the same inclination up to first frequency is 2 radian per second, then from 2 to 5 it will be with minus 40 dB slope, then from 5 to 10 it will be with plus minus 20 dB slope. After minus 20 or after 10 frequency, it will be with minus 40 dB slope. Okay, so like that you have to construct this magnitude plot and this phase plot. And if you observe this phase plot, it is nowhere it is having the intersection with 180 degree line. It is having intersection with 180 degree line at omega equal to infinity. So your omega PC will be infinity and gain margin will be infinity. Then look for this magnitude plot where it is having the intersection with 0 dB line. From that point draw the vertical line, and distance between that phase plot and this 180 degree line will be phase margin, which is 42 degree in this case, and this respective frequency will be omega GC, that is gain crossover frequency, which is 4.4 radian per second. Now the next problem, sketch the Bode plot for g of s equal to ks square divided by 1 plus 0.2s into 1 plus 0.02s. Okay, so here if you observe the and determine the value of k for omega gc. So here if you observe the given function, so it is in the standard format, that is 1 plus t of s, this one. Okay, so no need to convert anything here. And here he asked us to determine the value of k for omega gc equal to 5 radian per second. So in previous problem what he is to ask is to ask us the gain margin, phase margin and omega gc, omega pc, where the k is known in previous problems, but here k is unknown. So to have omega gc as 5 radian per second, what will be the value of k? That is the given question. So first we'll construct the table itself. So here in this problem directly I am constructing table, otherwise first you need to write those, identify those factors. So term k s square 1 divided by 1 plus 0.2s, 1 divided by 1 plus 0.2s. So here since it is s square, so the slope will be plus 40. Here I am taking this as plus because it is in the numerator, it is a 0. Okay, and for this minus 20 and minus 20, k is unknown, so magnitude will be 20 log k only, and for this the frequency will be 1 radian per second with 40 as plus slope as the cumulative slope. Second frequency will be omega c1 will be 1 divided by 0.2 because t1 is 0.2 here, so it is 5 radian per second. Similarly omega c2 will be 50 radian per second, and the cumulative slope if you take plus 40 minus 20 will be 20, 20 minus 20 will be 0. So 0 slope is for the last term. Then you have to construct the phase angle table. For that, in place of s you can substitute j omega square. So if you substitute that j omega square, it will be 180 degree, and this is the numerator term with the positive sign, denominator term with the negative sign, minus tan inverse of, here it is 0.2 omega is the imaginary part and real part is 1. Similarly for this, and vary the omega values from 0.1 to 100, and at the end it is infinity, and calculate their respective resultant angle. Now after that, after constructing this table, should go for the plot. Okay, so here first what I will mark the 0 dB line here. Okay, then the slope lines, first I have to mark a point on 0 dB line where omega value is 1. Omega value is 1 here. Okay, so I am marking a point here. Then in previous problems we used to mark the slope from this side, right? But here the required slopes are, all the cumulative slopes are positive. Okay, that means they should start from 40 and they should end at 0. Okay, so for that, here this is 40, this is 20. Okay, so now the first term for the s square term, I have taken the s square as the first term, that is a 0. It should be with 40. Okay, should be with 40 up to the first frequency, first break frequency. So the first break frequency is omega c1 is how much here? 5 radian per second. So that means from this value up to this omega c1, so it will be with 40 as the slope only. Okay, then the next frequency is 50. So from 5 to 50 it will be with plus 20 dB as the slope. That means it should be parallel to this 20 dB slope line. Okay, then after that it is with the zero slope. Okay, so that means this is the magnitude plot without K. First, starting from this 40, having the intersection at omega equal to 1 with the same slope, it will continue up to the first frequency, which is at 5 radian per second. Then from omega C1 to omega C2, it will be with plus 20 dB as the slope. Then after that the slope will be 0, because in this table, from this table you have to draw that one. This slope you have to consider. Okay, now we have the omega values and we have the different angles. So if you observe this phase plot, phase angle table, all are positive angles only. So for that we will start with the 0, mark a 0 line, then mark the angles, take the scale as 1 unit equal to 30 degree, and here as I said, first one will be 0.1, 0.2, 0.3 up to 1, then 1, 2, 3, 4, 5, 10, like that you have to read this scale. Then mark the respective angles for the different values of omega, then join those points with a smooth curve. Okay, now what he has asked, he asked us to calculate the K value. So to calculate the K value, he has given one condition, that what is the value of K if omega GC is 5. So earlier in the previous problem we used to determine the omega GC based on the intersection of magnitude plot with the 0 dB line. That means wherever your magnitude plot intersect with the 0 dB line, from that point we used to draw a vertical line towards the downside up to that omega line. Wherever that line intersect with that omega line, that omega value, that is that frequency value, we are going to take it as gain crossover frequency. But here we know that equation, we know that value, that is we know that frequency. From that frequency we need to calculate the value of K. So now I will mark the omega GC, it is given here, it is given in this statement. From this point I will draw a vertical line up to this magnitude plot. Okay, so according to the standard condition, wherever we are considering the omega GC, at that point this your magnitude plot should intersect with 0 dB line. That means you need to shift this magnitude plot by a distance of this much, that is by a distance of 20 dB. Okay, so shift this entire plot where it is having intersection with 0 dB line at this point. So for that it is required to shift 20 dB from the existing place. Okay, so when you shifting, the slope or the inclination should remain same for all the points. So it is with K. Okay, so measure this distance. So this distance will be equal to 20 log K equal to minus 28 dB. So from which you will get K as 0.0399, which is equal to 0.04, to have the omega GC as 5 radian per second. Okay, so here the only thing is, after construction of this magnitude plot, first you have to mark omega GC at 5 radian per second. From there you need to draw a vertical line up to this magnitude plot, and whatever the distance is there, that distance you need to measure, and you equate that distance to 20 log K. From that you have to get the value of K, and you have to shift this entire plot at this point. Okay, so with this we'll conclude the today's session here itself. So in the next class we'll try to solve few more problems or few more varieties of problems on Bode plot. So here you just try to remember two things, that is, if you want to calculate the gain margin, that is from this problem you can understand. Yeah, here. So how we got this omega GC value? We are looking for the magnitude plot, and wherever it is having the intersection with 0 dB line, from there
you have drawn a vertical line. So that is going to be your omega GC. Okay. Similarly, omega PC will be intersection of this phase plot with 180-degree line, and you have drawn a vertical line up to this frequency line. So that is going to be omega PC. Similarly, at the same point, the gain margin you will get here, and phase margin here you will get. Okay. So in the next class, we'll try to solve few more varieties of problem. So if you have any doubt, you can leave the comment in the comment box. Thank you.